Hello. This is going to be kind of a, a walkthrough to start the Tic-Tac-Toe program, and it'll be kind of this set you up for completing that, and kind of and the right direction to go in. We're going to start with the project first. And I'm using an older Visual Studio. You can use the community version, anything more up to date. You would have to research whatever version you're using of Visual Studio. Research how to create an empty console project for C++. That's what you're going to research when you create a project, and it's going to be an empty C++ console project. And when you do a search for it, just search for the version of Visual Studio you're using and empty console project. Search for that and you will find instructions on how to create a project, etc. So we're gonna create a project, our C++ project, and this will be our starter for having fun and writing some code for the course. Select the empty project for C++ Windows Console, however your version does it. Okay. And it could be an empty console project, but that creates some stuff that I don't like. And I always like to put things on the desktop. And I'm going to call this Tic-Tac-Toe. All right, our project folder is available to us. Tic-Tac-Toe. And I'm gonna go ahead and just add some files here. It's gonna be text and we'll add it to the project. This one will be main.cpp. And then I'm going to have another one called Tic-Tac-Toe. .h. And we're going to build a header file. We're going to do it inline, so we're not going to mix up with a tic-tac-toe.cpp. We'll put all the functions in line into the object. Oops, we need to actually add that to our project. So we've got the files created. And what I'm going to do is I'm going to go here to the project. And I can go into the source files and let's add new item. And let's see if we can't, oh wait, existing item. All right. So our tic-tac-toe is going to have a two-dimensional array. And let me we're gonna go ahead and begin our project just to get something going. And then we're going to add in the tic-tac-toe.h file, include it, and then write some code in there. That's where it's at. I've been working with multiple different languages, so sometimes I'm going between them. Okay, yeah, we need int there. That's true. Okay. Yeah, because we gotta return something to the process initiator, and we have everything we need to begin here. Save all. Let's just run it. I want to see if the project's going. Okay, we're good. Hello world. All right, now we're gonna go up here. I'm gonna add the existing item, and it's gonna be tic-tac-toe.h. Now this is where I'm gonna go ahead and I'm going to declare a class called Tic-Tac-Toe. Define it. And in that class, we're going to have an array, and we're just going to start with the array. It's going to be a private array. It could be anything really, because we're going to just determine on whether, you know, whose play that is. And it can be but it's going to be a 3x3 array. We could just assign it number 0 for not chose, and we'll assign 1 to a value in the array for x, and we'll assign 2 to the array that we're going to store for an O play. So what does our array look like? And what are arrays? Look at the array video that's in some of your modules coming up, and you'll know what an array is. I think it's next module. You know, it's in one of them. We got tic-tac-toe. We're going to have an int array, and I'm just going to call it data because it's private. The people that are using it shouldn't even know about it. Because what we're going to have is essentially in this class, we're going to have a function. The only function that we care about is, you know, a start function, and the start function is going to be where everything happens. And in fact, this could be in the constructor, but the user of this would probably want to just start the game, and that's, you know, we're just going to have everything happen in the object. So that means then that we're going to treat this start function like our new main, and we got some issues there that I will deal with. But this will be where we want to do our hello world. Let's be simple and not, you know, get too far on things. I'm going to do here, I'm going to include, because we're going to do some output from this object, because it's going to play our whole game. And then we're going to do this in main, and I'm going to go ahead and put our hello world, because start's our new main. So we're going to do everything in the object itself, the whole game, and all main does is instantiate start. And in fact, we can call the start function from the constructor so that it does just that. It'll call automatically the beginning of the game, and all we have to do is run the constructor. And we could even make this private, but this is public. Oh, that's right. No, we need the constructor public as well. And the data, we're going to make private. I think that works. So now what do I want to do? Well, I just want to instantiate it and see if it starts up from main. I'm going to include tic-tac-toe.h in main. So I'm going to go up here. I'm going to say include tick, and there it is. Pops up. So it's most likely going to see it and do what I want. So I'm going to say tic-tac-toe. And I'm going to create a game. And the constructor, when this instantiates, the constructor will call and go into ours. Let's just set a breakpoint just so that we can verify some things. There we go. Oh, it didn't let me step into it. That's a, oh well, that's all right. Did we get some output? Let's hit continue and we'll see if we got some output. Doesn't look like it liked that. So let's see what happened. Did it even run? Let's get rid of this then. All right, then we're stuck with figuring out what's wrong here. Oh well, oh, looks like we got the news. One thing to fix is this. This is what's causing the problem. I believe a copy constructor is needed, but that's fine. So now I'm just going to test it. I'm going to see if I can't get into the library. Make sure all our connections are done right, and I'm going to do a step into here. Okay, we have our tic-tac-toe library ready to go, and all we have to do is work in main, which is that start function, and we have it. So everything's going to be done here. Start. And what is everything that's going to happen? Well, we're going to do something with this data. And the first thing that we want to do is we want to assign it a value so that it's initialized to its default state. And to begin that, we probably would have a function that start would call, and it would be called it would be initialize. And a lot of this should be done in the constructor, but you're often going to want to call an init function that does the same thing as the constructor. And it's just, initializing your data. And what we're going to do is we're going to loop 3 by 3 times. to traverse that array and assign default values that means that there's been no play. We're going to use 0 for referring to a place on the board that has no play in it. And so that's what we're using these for loops for, is just to initialize the data that we're working with. And so that step is going to happen in the constructor and the init. And in fact, you know, it might be better just to call init from here and throw in this down here. Yeah, let's do that. That's so much cleaner. Let's do init, a call to init before start. And then this will be kind of like you reset the game. So everything that you have in init just resets the game to its default state. Whatever variables you need for that, like maybe the play count, that's something that you're going to have. All right. What do we need to assign it to? We're going to assign each row and column value equal to 0. So that initializes our array. On startup, and it should be done before this happens, but what else are we going to want? We're going to want something that prints the array. And it's going to use the same loop, and for every row or for every column, print the rows. Or, you know, assign the data to the rows. Print the rows, that's what we're going to be doing for the print function. And it's going to just do a cout. And it's going to be a bunch of zeros. So when we start, maybe we have a menu here. Then we do a print. Let's print the current state of the playboard, just to begin with. Okay, so we start, we init, we start, we print. And if this is working in a loop, you're going to want to call init. So this would be where you put your gameplay loop. And that would be where you need to have the ability to move 9 times. It'll be probably you could do a for loop or a while some condition, and you're going to want to detect when the game's done being played, or when there's a win, and then reset for a new game. You can ask for yes or no, stuff like that. So the big thing is you're going to be looking at how to determine whether there's been a winner every time you play. So let's test this. It should be printing our zeros. Okay. Oh, looks like we have some issues there. We might have to dig into. Maybe let me save all. Rebuild. Maybe it's being a stinker. Because we got start, print the menu, start, and it happens. Then the print happens. Eventually the knit will happen as well. Together. Okay. Alright. Continue. Oh, dang. What happened there? Looks like I got an array out of bounds error. And you guys probably saw it from a mile away. When I was typing it in, I should not be iterating I even more. I would go up into the values of 4, 5, and 6. As soon as it was assigned, 3, or whatever, it died. This should be J. All right. Now we're done playing games. Let's give me something a little bit better than this. Well, why is that? Ooh, no, what? No. Oh, because why did it not? It should have saved that. That's unfortunate. Save all. Stop debugging. Now let's rebuild it. All right, now we can test it out. Still some more. I made that change. That's so weird. It's working against me. I don't know why. Microsoft. Okay, let's make sure you're darn well set, right? Oh, I had it in 2 spots because I copied and pasted. I'm like, it happened again. I just edited that. All right. Okay, there's our big line of zeros. Because I'm printing every row. So row 1, row 2, row 3. So I need to print some kind of new line after every row. And that happens in the where I traverses. That happens in this loop right here. For every row, print the columns. And so when we get down to the end of the row, so this is for every row, print each data item in that column. And it just prints out every row as it goes across, kind of the and so when every row is done, because this goes through every row and column, when every row is done, because this goes through every row, we want to do an end line. Just an end line. Something simple. Just to kind of give us it looks like we need an end line after menu. After we print menu. Let's just be lazy and do a \n there. Okay. See if we got our whoop whoop. Okay. So now we need something to make a play. A move. And we need an integer that refers to the player. So it's going to be 1 is going to be x, 2 is going to be O. And so this move, what it's doing is it's just going to change your array that represents the playing board. So we just need to pass the player, and we can ask the player here what they want done. And what we can do is let's do everything all in one function so that we don't have to deal with passing things back and forth to functions or from functions. So I think this would be probably a better route to go, because I just need the player number when a move is made, and I can put in some validations here, but I'm going to go ahead and do this. I would add validations here. I'm not going to put the time into it now, but I'm going to ask the user to enter row, and you can give them some instructions. 1 to 3. Well, you know what? We just need enter row position, enter row position. And you know what? Let's just ask for row, because then we know what row we're talking about. Easy. And then what I'm going to do is I'm going to do a cin of the row that was chosen. And that can be just an integer. And the user is going to enter a row number, and let's just tell them 1 to 3. We input the row. Then we ask for the column. Which is a duplicate of our next one. Enter column. I think I spelled that right. Column. So now what we're going to do is we're going to look at the move and see if it's adequate. Some validation. Row and column, you know, you can put some validation after each one. But what we want to do is we also want to check to see if any moves have happened. So if it's not 0, because 0 is our default position, 1 is X, 2 is O, we know what player we have. So what we can do is assign the row and column to a specific player, like 1 or 2, or it's going to be 0. So we can't make a move unless this is our first validation. If idata, and you would look at, you know, hey, is the row column entered 1 to 3? That's some validation I would expect. This is validation of the data itself. Like if there's already been a move, if idata of ij, if it's assigned equal to 0, and actually ij is wrong, row column. It's another one of those, it's gonna get you in the end. And if it's equal to 0, then yeah, you can change it. And you would do idata of I, j, oh, row column. Did it again. Oh my gosh. Of row column equals player. Because the player is going to be 1 or 2. You're going to assign that at the beginning when you start working on your game loop. You're going to have a game loop where you do a move. And then this is where I would put error, already moved. And you would also, check the row column values and make sure that they're good before you get to this code. I'm leaving that to you. What I'll do then is I would do a cout try again. That move is taken. Now this is where things will mess up with your game loop, because if you hard code it, the game loop, into running 9 times, and you do just 9 moves, and you get somebody that makes a play that it has an error, that's going to increase your amount of moves. So we don't want a loop that stops just 9 times and asks for 9. We want a loop that will go and decide that decide the end of the game determined on a while loop, and you look at the game characteristics to stop the loop. And you can use some of these functions to decide when to stop the game loop itself. We could also do a return here to return back to main that, oops, that move was not good, do another move. And we can actually even embed that into a while loop to continue. But we have the mechanism now, and so what I'm going to do now is I'm going to say menu, or no, what is it that we're doing here? We printed, let's do a move. Move player 1. Then we're going to have a move player 2. And let's just look at behavior, because this is going to be, these functions are going to be in the loop of what we do. What we do. Okay, and menu. Let's do a 1 and a 2. Okay, now it looks like I didn't print after each move, and I wanted to print after each move. So we print between moves. Okay. And then we print after this move. That would be in the loop. So we're gonna just kind of simulate a loop, just hard coding it. Okay. 1, 2. There we go. Now we would modify this to print an X instead of 1. Okay. Now I'm going to do the next player, and we're good. All right. So now we go to the print, and we're going to modify this to output X's or O's properly. And so we're going to say if this guy equals 1, then print we do a cout x, and that's going to be a capital X as a, we can do it as a character or a string. It's much better just to do it as a character. I think, yeah, cout should be able to handle that. Yeah. And then we're going to have an else if. If it's 2, we're going to output O. And then now we test. Oh wait, nope. I forgot. We got our default condition. That means that that particular spot has a 0. So we do a cout, or has a 0, yeah. A cout of, let's see. Let's do the asterisk for an an empty slot. That way we're not mixing it up with X and O. So we'll just do an asterisk for an empty slot to be played on the board. So now let's look at it. 1, there, 2, 1, there. Okay, good. Now, what are you going to have next? You're going to have a while loop in here instead. You're going to say while 1. Yep. You're going to have a function, and some functions will bounce out of the game. And the way that you're going to bounce out of the game is you're going to print, move, print, move, print, move. That doesn't need to be there. Let's throw another in between. We could clear the screen at this point. That would be kind of cool. Actually, let's do that. Yeah, I think it's just system dot. Yeah, it's this cout system CLS. I think that's it. Something like that. We're just putting a command right on the console. Let's test that. And yeah, we're going to this is going to be our break. Our break is going to be conditional. It's going to be conditional based, and it's going to break you out of this loop. We're only going to do one set of moves and then break. But after your set of moves, you're going to be looking at things and deciding that the game is over. So you might want to do a function that checks for any zeros that are left on the board. And as soon as that function detects that there's no longer any zeros, you would output draw, because sometimes what will happen is you'll get a draw for the game. And so you want to have a function that detects whether or not you have any plays left. Are there plays? Is the board full? That sort of thing. Another condition that's going to determine whether you call a break is going to be a function. And what you can do is, this is what we'll do, is we'll just do a Boolean. No, we'll do an integer. And that's going to be check when. And if somebody won, you would return the person that won, or 0 if there's no winner. So it's either 0, no winner, 1, or 2. 1 would be the winner for everything. And you can do this by just saying, hey, if, and this is going to be a very rudimentary if statement, you're going to have either more of them, or you're going to put them in, quote, you're going to use them with ors or ands. It would be, in this case, or. You would use the or operator between different, well, actually, let's just do it. If I data of 0, so we're just going to check the first row, equals, yeah, we're going to have to use and, equals 1, player 1, and idata, this is going across the first row, So we're going to be using 0, that's the first row, first column. The next row, the next column, same row, has the value 1. So this is going to be, these two logical expressions are going to determine, because they both have to be true. So that means that this one has to be true. Then also this one has to be true for the player that this outcome we're checking for. So that means that this player has played in this location. We're going to do another and, because we're doing the ands across rows. So we're going to keep the same row, 0, and then the third column, which we used 2. And if that's equal to 1, this really becomes a return 1, meaning x1. Else, this would be a no-win scenario, because you're going to add for the logic for the other player as well, which could be just more if statements. So you would have a whole bunch of if statements and only one else, because you just say 0, nobody won. And then what you could do over here is you could say if check when equals 1, that means x1, and again, I'm only testing one row. You will test all 9 different scenarios, crossways, left, up and down. Yeah. So if that is true from the check win, then that means we found a winning scenario. See out x wins. and then the game is over. We break out of the loop, or we could call init here, you know, or something like that, and continue play somehow within the loop. You could say init for a new game, like, would you like a new game? And then you just call init, and it sets up and it blinks everything out back to the playing board. And actually, I wouldn't do it here. I'd do it outside. I'd do it out here after it broke out. Then I would catch what was going on here and determine if they wanted to play again, something like that. But this will keep running until it gets a win. And again, you're going to want to be checking the whole board in between moves to determine if there's any moves left. That's where you also want to have a break statement breaking out. If there's no more moves left, and that means there's a draw. That means one of them didn't win and there are no moves to make. And so you'll have a check board function that checks the board for any zeros, unplayed spots, essentially. So let's go ahead and test this out and just kind of see behavior. I'm going to purposefully win. Oh, I put the wrong thing in. Dang. Okay, there's the board. It cleared. That clear screen could probably be somewhere better than this. Possibly. And the 2 backslashes are definitely a no-go. So this one I'm going to do 0. Because it seems like I've got a fence post. 0, 1. Yeah, 0, 2. 0, 2. I got a fence post. That means that in my play, oh yeah, that makes sense. I got to do -1 here. Because we need to convert it to array language. Because remember, an array starts at 0. So we're asking for 1 to 3 input when an array starts at 0. It's just better for the player. Okay. 1. And it'll be 1, 1. Oops, 1, 2. That's good. I moved to where I wanted to test. So I'm going to do 1, 2. And now I'm going to do 1, 1. So we got X's all the way across. Now this is for O. You're probably going to want to say player O, make your move, stuff like that. Clean up this clear screen stuff. But now it's O's turn. I'm going to do 2, 1. All right, now I'm testing my win scenario. I'm going to do 1, 3. Okay, now where's my check win? Oh, it's asking for one more move. This check win should be between your moves. Yeah, okay, so it's asking for one more O move, even though it's 1, 1. So your check win needs to be between your moves. So once we get through this move, there you go. And that kind of gives, hey, the move is taken, X wins, and we broke out of the loop. Even though it allowed O to play again. So what we do to fix that is just take this guy and put it here. We still want to print the board, but we also want to check the win. Because printing will print the winning move. Then the other guy gets to move. Loop starts over, prints. And we probably want these two lines up here. Clear the screen when we start. And what we should do is clear the screen after all two moves. So this will be where we want to, you may need to play with where you're going to clear the screen for your kind of persistent menu to be up and to your left. So you're not just playing line by line. And of course you could just take that out. So this is your starter. You're going to need to do those functions I discussed, like checking the board if there's any more plays, implementing all the if statements that you need for this part. Move is good. Print is good. The init, that looks good. So in your game loop, you're going to want to add a check board function. And that just should check to see if there's a draw. Check board. That would happen probably here. But actually I would do it after the check win. And then check the board to see if there's any more plays. If there's any more plays, then you don't do anything. If there's not, use break and break out of the loop. Game over. Yeah. Okay. Let's just play with it. 1, 1, 2, 1. It looks like it's printing a 0 there for some reason. That needs to be fixed. 1, 2, 2, 2, 1, 3. Okay. X wins. All right. Why is it printing that 0? It's probably going to drive me insane. It's somewhere in there. To find that out, I would just check my print statement, my initial print statement. And actually I just want to start here and just see if it is indeed the first print that does it. Yeah, it is. Look, it's got the 0 and a menu. So that means it's either something after or before. No. Okay, this is driving me insane already. It's the mystery of the 0. Where's the 0 coming from? Yeah, I found it. Yeah, I'm being silly. You don't see out the command. You just make the command. Yeah, that was interesting. So here, I'm doing it right there too. There we go. Now it's going to behave a little bit nicer. A little bit more pretty. There we go. 1, oops. Oh, let's get in there. 1, 1, 2, 1, 1, 2, 2, 2. Oh, that's a problem. That's going to be, I'm going to mess that up. Okay. Now let's do 1, 3. X wins. Broke out. Okay. All right, guys. This is all for you. I'm gonna go ahead and give you just kind of an overview of the code, so you have it. Let's actually zoom in even a little bit more. Okay. And let's start with main. Here's main. Just just instantiating it with the IO stream. Here's our Tic-Tac-Toe class, and we're gonna declare the class. We call an init and a start function. When it's kicked off, we have data called iData that represents the playing board. We've come up with a mechanism. 0 is for no play, 1 is for player 1, 2 is for player 2. So we init everything to 0. We also have a print so that we can print X or O depending on our mapping of our data, our 3x3 array. We make a move and ask the user to enter values that represent row and column for their play. So you may want to actually enter in here player 1, what's your play, or something like that. Maybe something that output what player is actually in play when you ask for the row and column. So you might want to print out player here. Player 1 or player 2. I believe we'd use the 0, 1, 2 as with the player. No, just the 1 and the 2. It's the same thing. It just directly corresponds to the array. Then we got an example of your check win. Hey, what does that look like? If it doesn't find a win, then it returns 0. False. Nobody won. So you can actually just return 0 or 1, because 1 becomes true and 0 is false. So that means that 1 means X1. So you could actually just call check win here and not have the equals 1, and the 1 would relate as a Boolean in C++. 0 is a false, 1 is a true when you're working with regular expressions. It's just the default. So even though you use false and true, it's still just 0 or 1. But that gives you everything. Okay, that's a start for you. Thanks. Bye.